So my name is James Golick. I'm at James Golick on Twitter. I blog at jamesgolick.com, GitHub/James Golick. I'm also James Golick on Freenode. I go by James Golick pretty much everywhere. If you have comments, concerns, death threats, please get in touch with me if you don't get a chance to talk to me in person at the conference. I try to be very accessible, but just don't email me if you want a response. So I'm very bad with email. So I'm the CTO of a company called Protos, which sounds kind of corporate, but actually, actually Protos is the name of the company that runs FetLife.com, which is the largest social network in the kinky and BDSM communities. So we have just under 500,000 members. About 1.5 million pictures have been uploaded to FetLife in the last couple of years. And we do somewhere around 180 million requests per month worth of traffic, right? And that sounds like a really big number, and I put it in a really big font on this slide, and it has a lot of zeros. But the truth is, like, we peak out close to kind of 250 requests per second, in and around there, right? And in the grand scheme of things, that's actually a relatively small number, right? If I were, here presenting on behalf of like a Twitter or a Facebook, we'd be talking about several orders of magnitude more throughput than that. And so I think what that means is that our scale is a lot closer to the average web app than it is to these web apps at massive scale. And so I hope that people will walk away from this talk with some new thoughts about some of the tools that they actually use in their day-to-day work that are actually somewhat applicable to that. So when I joined the company, we were hosted on Engine Yard, on their private cloud. And at the time, we're doing about 50 million requests per month worth of traffic. And we're hosted on 5 virtual machines, right? And the way that Engine Yard's private cloud works, or at least the way that it did work at the time, was that you rent N web tier virtual machines that run your Nginx and your Mongrel and your Memcached and your background queue workers and stuff like that. And then you get space on these 2, or on this one really, shared database infrastructure, unless you pay more to get your own dedicated cluster, right? So really, we've only got these 3 VMs at the top there that are running our web tier stuff. And so that's 5 VMs, right? And so for all this talk about Rails being slow and Active Record being garbage and destroying the performance of everything and Ruby being too slow and we need to all go to JavaScript, like here we are serving more traffic than almost any web app ever gets on 5 virtual machines, right? But we're going to get to that. Our response time, 275 milliseconds on average. And there's been some crazy talk about, like, I optimized my site and I came down to 500 milliseconds, and now it's awesome. 275 millisecond average response time, pretty slow, right? And I remember, back in those days, I thought for a second maybe like lolcats was dead and I should take all the rest of the cat pictures out. But anyway, so I remember back in those days, John, my business partner, and I used to sit on Skype during peak hours and watch the response time climb up to like 500 milliseconds, 1 second, 2 seconds, 3 seconds, and just watch in horror. So there was nothing we could do about it, right? And so we knew we needed more hardware. We knew we needed more capacity. But the thing about Engine Yard's private cloud is that they do all of the operations for you, which is awesome if you don't want to do operations, right? But what that means is that if you want to buy more hardware for your cluster, it's expensive, right? And being a bootstrapped startup with no revenue model, we couldn't really afford that. And so we start realizing that we kind of need to go somewhere else. We kind of need to take, unfortunately, we kind of need to take control of our own operations. And I loved the mention of the one-man dev team because, I'm a one-man dev team, right? And, John takes care of, John, I took away your commit bit a long time ago. So, John takes care of business, John takes care of design, but I do all the programming. And so taking control of our own operations meant I was going to be the sysadmin, right? And there was only one teensy problem with that, which was that I didn't have a fucking clue how to do that. And so when we started evaluating target platforms for FetLife, the only Rails sysadmin work that I had ever really done was on EC2. And so there was a convenience factor there. And that was I was like, yeah, we're moving to EC2. End of story, right? And beyond the convenience factor, I was also I was kind of drooling a little bit over, I don't know if you can see there's a huge glob of drool coming out of this dog's mouth. But anyway, I was kind of drooling over stuff like auto-scaling and all this cool automation stuff, Chef, Puppet, whatever. And so I think that was a big reason that we wanted to move to EC2 was because I wanted to play with all those cool toys and scale our cluster horizontally and say that I was managing 50 servers and whatnot. So for these bad reasons, we decided to move to EC2. And at the time, we're serving, I don't know, about 70 million requests per month. This is a few months after I joined the company. And our initial infrastructure on EC2 was 7 web tier servers. Maybe it was 6, I don't know. But anyway, again, master-slave MySQL server, and the slave is just there for operational purposes, for hot failover, for backup, stuff like that. We're actually only querying the master. And then a MongoDB server, which we'll talk about later in the talk. And so, obviously, if we need 7 web tier servers, and we've just gone from 3 to 7, these machines that we're using on EC2 are somewhat less powerful than the VMs that we had on Engine Yard's private cloud. But that doesn't matter, right? Because we're on the cloud, so we can just scale out, right? And we did scale out. And then we scaled out more, and we scaled out more, and more. And when we first moved over to EC2, our response time, our average response time was about 220 milliseconds on average, with actually a relatively high standard deviation. So faster than Engine Yard, or faster than we were on Engine Yard, but still relatively slow. And if you don't get this joke, these guys are speed walkers. But there's something kind of funny about this picture that I noticed, which is that 2 of the guys actually have both feet off of the ground, which I thought was called running. So to make a long story short, at this point we decide, maybe we've outgrown this whole cloud thing, right? And I kind of, push my obsession with auto-scaling aside, and we start evaluating physical servers as a potential target for our next hosting platform. And so we ended up deciding on this hosting company rather, called SoftLayer. And there's a couple cool things about SoftLayer that really attracted us to them. So number one is no contracts, right? If you're a startup and you're on EC2, one of the best things about it is if all of a sudden your traffic all disappears tomorrow, you're not on the hook for the remainder of your contract, right? If you're on Rackspace, you're talking about 1 year minimum, and a lot more than that if you want to get decent prices from them. So the second thing was that SoftLayer offers 2 to 4 hour addition of new capacity. So it's not 5 minutes. It's not API-based. It's not API-based server provisioning, but it's a hell of a lot better than 5 to 7 business days at Rackspace. So our initial infrastructure at SoftLayer looks a lot like what we had on Engine Yard's private cloud. 6 machines, including MongoDB. 3 web tier servers, MySQL, master slave, and this MongoDB server. And not having really had any experience at all with physical machines, despite the fact that our benchmarks showed that this infrastructure was extremely fast, I was a little scared that there was something that I had missed, right? That maybe our benchmarks weren't representative, or maybe I just completely overlooked something But when we flipped the switch, we were greeted with a pretty nice response time of 98 milliseconds with a relatively low standard deviation. Right? So this is a lot better. I mean, we more than doubled our performance here. And so all of a sudden, overnight, FetLife goes from being this incredibly slow site to being this incredibly fast site. And we didn't do anything, right, except buy servers. And the servers cost less than what we had on EC2. So here's a fun graph of our response time from the day after we flipped the switch over to soft layer being compared to the week before on our EC2 infrastructure. So this light blue wavy line, this horribly erratic performance, is our EC2, horribly overloaded EC2 infrastructure, I should say. And then this nice yellow, fast, consistent line, that's our new physical hardware on soft layer, right? And so it was pretty clear to me at this point, and remains clear to me today, that physical machines are a lot faster than what you get on EC2. But I was kind of curious, like, how big is the difference? So I use a tool called Sysbench, which is commonly used for benchmarking MySQL infrastructure. The Percona guy, if you read the MySQL performance blog, the Percona guys talk about that a lot, use that tool a lot to benchmark various pieces of new infrastructure. And so I ran a couple of tests. The first one was a CPU test, calculating max prime numbers up to 50,000 in 16 threads. And the EC2 CPU performance, and I should say, let me back up a second and say that I'm comparing here two identically priced machines. So that, not identically, but within plus or minus $20 of each other. And so the physical machine was a dual quad-core Nehalem E5520, if you're familiar with that processor, with 36 gigs of RAM and four 15,000 RPM disks in SAS disks in RAID 5, in hardware battery-backed RAID 5. And then the EC2 instance was, fucked if I can remember the name, double extra large super high memory instance or something. What's that?
You forgot secret probation.
Right. And so, on average, this EC2 instance is about 2.5 times slower, taking 2.5 times longer to execute this benchmark, right? But what's interesting is the variance. If you look at the 95th percentile and the maximum, SoftLayer's maximum is maximum time it took to execute this benchmark was 2.5 times the average. It'd be nice if they provided the standard deviation in this tool, but nevertheless, this is what we have to work with, right? But EC2, the time it took the EC2 instance, the maximum time to execute this benchmark, was like 150 times its average. And the 95th percentile is kind of similar, right? And so EC2's performance, CPU performance, was about 2.5 times slower than SoftLayer, but it also had like a massive variability in the time that it took to execute this benchmark. The next benchmark I ran was file I/O benchmark. So this is random reads and writes. It's combined random reads and writes. And the numbers look kind of similar, right? 16 threads again, max file size, 3 gigabytes. SoftLayer performing about 6 times better. I mean, the physical machine, rather, performing about 6 times better than the EC2 instance. So, given that these machines are equivalently priced, you're paying a lot more for your horsepower on EC2, a lot more. And when you consider I/O, like 6 times, potentially. And I should say that I also ran an OLTP test where Sysbench actually fills up MySQL with data and then runs queries against it and measures the results. I took out the slide because the results didn't make sense, and so I figured there was something wrong with the benchmark. It showed about 50 times worse performance on the EC2 instance. That didn't really make a whole lot of sense to me. But the machines were running the identical OS, had the same MySQL configuration, had about the identical amount of RAM. I did zero the disk on the EC2 instance before running the benchmark. So I don't know, but that's what the results were. So they say EC2 is fast enough, right? The proverbial they. But data from Microsoft, Google, and Shopzilla shows that Slow sites get fewer search queries per user, less revenue per visitor, fewer clicks, fewer searches, and lower search engine rankings. Right? And let me unravel that. Right? That means that fast sites retain users better, make more money, and rank higher in search results. Right? Fast sites retain users better, make more money, and rank higher in search results. And we have seen this in action at FetLife. And we have seen as much as a 1% loss in revenue per millisecond of average response time. And this is out at already fast speeds of 100 milliseconds. So 20% between 100 and 120 milliseconds. And we've seen this consistently. So it's hard for me to understand why anybody would really be willing to give up any significant amounts of performance for any reason. Right? And so when I hear people at conferences talking about 500 milliseconds being the highly optimized version of a page, it's kind of like, well, you're shortchanging yourself from a business perspective. Right? Because performance it's not a feature, it's a requirement. Right? I mean, if you want to make money and retain your users, and place well in Google results. And so there's one other aspect of the whole EC2 argument that I want to address. And that is this notion that, yes, the servers are slower, but it doesn't matter because it's so awesomely easy to scale on EC2, right? You've got your chef and you've got your scripts, and you can bring up new capacity with the click of a button or the running of a shell script. And we did this when we were on EC2. We brought a lot of new capacity into our cluster in this kind of highly automated way, and it was awesome. Well, it felt awesome. But one of the things that I've certainly noticed since we moved onto physical hardware, onto considerably less physical hardware, is that there was a lot of overhead, a lot of management overhead associated with running those additional machines. Right? One of the things that happens to us on occasion, and it's always happened, and it happens once in a while when we deploy new configuration changes or whatever, is that one of our web tier servers starts acting funny. I don't know, configuration problem, hardware problem, could be a variety of things that cause it. But the idea of diagnosing, what you suspect might be that problem on 30 web servers compared to diagnosing that problem on 3 web servers is a huge difference, right? It's probably 10 times harder. Take you 10 times longer to find. And so all this automation stuff is great. It's great. I mean, I spoke about Chef at Mountain West. I love it, and we still use it. But it doesn't help you debug production problems. And so, the fact that it may be easier to scale out on EC2 is completely overshadowed by the fact that EC2 forces you to scale out much sooner. We are still running on those same 3 web tier servers, and our traffic has more than tripled since then. And I would suspect, given the performance data that we have, that our traffic could double and then double again on those same 3 servers, just to give you an idea of the scale of the difference between what we had on EC2 and what we had on these physical, and what we now have on these physical machines. So I want to shift gears a little bit and talk about something that I call service visibility. And what that means will become clear in a second. So the first queuing system that we added to FetLife was the once popular Starling Workling combo. And one of the things that would happen to us on occasion is that one of the queues would get incredibly backed up. We have big problems sending email, so often our email servers will get overloaded and our email queues will become incredibly backed up. And there are a variety of other things that would happen and cause this symptom. And so using Starling's runtime data, it was possible to figure out which queue was the problem. But there was absolutely no way to figure out why it was happening. We couldn't figure out if jobs were failing. We didn't know whether jobs were mostly succeeding or mostly failing. I mean, we could have written our own stuff to do it, and we did a little bit, but there was nothing built in. And so, in the spectrum of visibility, like this Starling-Workling combo as a queuing system was mostly opaque, right? And so Rescue really gets this right. You've got this amazing dashboard full of great information, tells you what all your workers are doing, how long they've been doing it. You can drill down into failed jobs. You can figure out how many jobs are failing, how many jobs are succeeding, get all kinds of statistics, trend those statistics, alert on those statistics. So this is really useful information, right? And you can kind of tell that Rescue was written to be run in a different kind of environment than Workling, right? Workling is good, and I'm sure a lot of people have had a lot of success with it, but obviously, or maybe not obviously, but I would assume that people weren't ever using it in an environment that had dozens or hundreds of workers, whereas the GitHub guys, they clearly wrote Rescue for a very demanding production environment where they were going to have to debug production issues with hundreds of workers and lots of jobs. I mean, they create millions of jobs, right? And so what I've realized over the time that I've been scaling FetLife is that this issue of service visibility can really help you distinguish between software that was just written for a small or toy app and software that was written to be used in demanding production environments, right? Obviously, there's a massive difference here, and the degree to which software exposes runtime data, I think, is a really good kind of initial benchmark for what kind of environment that software has been used in and how battle-tested it is. So the last topic I want to talk about is NoSQL. We've run a whole bunch of NoSQL databases in production to varying degrees of success. And the first NoSQL database that we ran was MongoDB. And we fell in love with MongoDB for the same reason that everybody falls in love with MongoDB, right? It's an amazingly rich data model, great queries. It's not like a key value store where you're like horribly constrained to like one type of query or maintaining your own inverted indexes. And we were also attracted to the performance, right? I mean, if you've seen any of the marketing materials on MongoDB, you know that it's like sub-millisecond query times all around. And that was awesome for us because we were using MongoDB to store our activity feed data. And that data set grows at about 20 gigs per week then and more now, totaling, at least in that schema, just under 1 billion rows a month. So we needed this high write capacity, and MongoDB provided it for us. And so we saw those kinds of query times for a while, and it was awesome, and the site was just humming along. But then, I think when we had about 150 gigs of data in it, things started to go a little downhill. And those queries that were taking, 1/10 of a millisecond or less than that, were all of a sudden taking several milliseconds or tens of milliseconds. And that was a big problem because MongoDB locks the world on virtually every query, or at least it did back then. I know that's gotten somewhat better now, but back then, reads, writes, deletes, everything locked. And so, we decided, we should try to clear out data from Mongo, right? Because it's, MongoDB was running great a couple weeks ago with 100 gigs. Now it's not running so great with 150 gigs. Let's clear out some data to make room for the new stuff, and hopefully performance will get better again. So we started running these big deletes, right? But turns out Mongo also locks on deletes. So we were kind of stuck between this rock and this hard place where we needed to delete data to keep the site running, but deleting data would take the site down. And the whole episode didn't end all that well. And this is actually really hard for me to talk about because it was my mistake, right? I did not evaluate MongoDB carefully enough. I mean, that's pretty clear, right? I didn't fill it up with enough data. I didn't put it under enough stress. I didn't, and again, I'm really embarrassed to say this, but I didn't find out about how aggressive it was with locking until it was 2 a.m. and the site was down, right? Not good. So after this, we decided, maybe we're going to get out of the NoSQL pool and return to something that we know how to run, which was MySQL. So I wrote a gem called Friendly. And Friendly is based on an article which I'm sure many of you have read called How FriendFeed Uses MySQL to Store Schemaless Data. And so, with 1 billion rows a month, we had this problem where if we wanted to add a field, we were pretty much fucked. If we wanted to add an index, we were pretty much fucked, right? I mean, that's like days, even on big hardware. And so what Friendly allowed us to do was store data that had no schema in a data storage engine that we knew how to back up, we knew how to performance tune, we knew what kind of hardware to put it on. And the way it works is that each entity, each kind of document, has a table that looks like this, right? So 4 fields in the table, ID, which is a 16-byte field, which is a UUID, created and updated timestamps, and this attributes text field. And the way the gem works is that it serializes the attributes of the model to JSON and then stores it in this attributes text field. So you can add and remove attributes at your will. Only problem with this is that you can only query by primary key if you have it. So the solution there is to create an inverted index table that looks like this. So this is a table mapping user.name to user.id. And so the way that Friendly does queries against this table is that they're done in 2 stages. So you query this table for a bunch of IDs, and then it queries the entity table for the actual documents matching those IDs. And so this worked really, really well for us for a while. It was one of the advantages to this kind of model is that it drastically constrains your query model. And so putting like a write-through and read-through caching layer on top of it is really, really easy to do and doesn't take very much code. And actually, Friendly comes with read-through and write-through caching built in. And we saw 99.8% cache hit rates in production consistently with that. So big win, very, very fast. But eventually, we started outgrowing the potential write capacity of the MySQL server we had, which had a lot of disks in it already. And upgrading to a MySQL server with more capacity was going to cost us a hell of a lot of money. So we started evaluating distributed databases, and we landed on Cassandra. And this kind of part of the talk is kind of boring because Cassandra mostly just worked for us. I mean, there's really not a lot to say. We evaluated it, we installed it, we set it up, and we ran it, and it was fine. The only thing I will say is that read performance, still not quite there, but getting better very quickly. And given the number of big companies that are starting to adopt Cassandra, I think it's going to remain one of the front runners in this kind of distributed database market. So I want to draw some conclusions from some of the things that we talked about. And one of the kind of themes, if you will, of this talk has been failure, right? Failure of EC2 to perform adequately for us. Failure of MongoDB to perform adequately for us again. But I want to make it clear that the talk's not meant to be a condemnation of those tools, right? Those are both great tools, and I would still use them, depending on the situation. If anything, what this talk is really meant to be about is, mistakes that I've made as a sysadmin, right? And when you really look at all these decisions, and you really look at all of these failures, what you see are, instances where I didn't evaluate things carefully enough, right? Where, I drank too much Kool-Aid, if you will. And, in the case of MongoDB, I should have known about the locking much sooner. In the case of EC2, I should have evaluated the performance of physical servers, given, my ignorance of hosting in general at the time. And then, on the flip side of the spectrum is Cassandra, right, where we did evaluate it very carefully. I read the relevant research papers. I reread the Dynamo paper. I read the Bigtable paper. I read papers on distributed systems. We put it in production for a couple of weeks without anybody actually reading from it to make sure that it could actually handle our data volume. And this was one of the best decisions that we've made in recent memory. And so if there's been one overarching lesson that I've learned from scaling FetLife, it's that the most important thing that you can bring to any engineering problem is knowledge and understanding of your tools, and that believing in the hype will only get you into trouble. Thanks. Questions? So the question is, when we evaluated Cassandra, how did we write to Cassandra in production without coupling our production traffic to that, and how do we evaluate the performance of it. So what we did was essentially all the activity feed stuff actually gets written to the underlying data store in a rescue job. So inside of that rescue job, we created two models, one for Friendly, well, we already had that at the time, and then one for Cassandra. And inside of that job, we just basically created both models and then saved them both. And then we just measured, Cassandra exposes a lot of performance data, and we measured that and ran queries against it with data in it to determine how it was performing, and obviously measured things like load average and CPU and memory usage on the machines. So how are we load balancing on EC2? We tried a couple of things. At one point, we had two dedicated HA proxy machines, and at another point, we had HA proxy running on each of our app servers, with one being the kind of master load balancer at any given time, because since all the app servers are completely symmetric. So the question is, generally, Cassandra's read performance is 5 to 10 times faster than on MySQL, and so how come our performance was okay on MySQL but not on Cassandra? So for pure key lookups, just one key to one value on Cassandra, if the value is very small, so I don't know how many of you are familiar with Cassandra's data model, but it's essentially nested hash tables, and you use underneath one key, you can put in a bunch of keys that each have their own value. So for example, like one row would store all of the data for one object, one active record or Cassandra object. And I'm sure that's a terrible explanation, but the Cassandra data model is very, very complicated, and it would require some visuals to actually explain it properly. But if your rows are small, that's true. If your rows get big, it's not true anymore, and performance becomes very, very, very slow. And I actually submitted some patches that improved that by a lot. But the other problem big problem for us is multi-get performance. So multi-gets in Cassandra, memcache is like 200 microseconds to do a multi-get, and in Cassandra, like our multi-gets for 1,000 keys are like 80 milliseconds or something like that, which is really, really slow. So hopefully that answers your question. So the question is, you have this constrained query model with Cassandra, incredibly constrained. So how do you do like business intelligence, right? Like how do you find out how many users you have and where they are and all that kind of stuff? So there are two answers to that question. First answer is, in our infrastructure, we only store activity feed data in Cassandra. And I think that's mostly the right approach, right? Like, I mean, we have 500,000 users right now. Even if we had 100 million users, we could probably still get away with MySQL. It's when you start getting up to like 1 billion plus records in a table that I would start considering moving to something like Cassandra. And so for us, it's not really an issue because we don't really need to do BI or any kind of like aggregate queries across our Cassandra data. The second answer is that if you absolutely do, you use Hadoop, and there's Hadoop integration around for Cassandra, and that's how you do analytics. So the question is, I said that we had a strong correlation between our revenue and our response time, and the question was basically, is it possible that that conclusion was confounded by other factors, that it wasn't actually related to response time? Because since we were on the same hardware, theoretically the response time would be consistent across those days. But, and yeah, it's possible. But, lost my train of thought.
The number that you gave, right, was 1% revenue per millisecond, right?
Right.
Which means that extrapolating from what you had already said on the new hardware, on the old hardware, you should have been owing people money.
Well, yeah. I mean, but I think, and I don't have any data to prove this, so take it with a grain of salt, of course, conjecture. But I think it has a lot to do with what people are accustomed to with your site. So if your site is slow one day, and to answer both of the questions sort of at the same time, right? It's, the site can be slow for a variety of reasons on the same hardware. We deploy code sometimes 10 times a day, and sometimes you miss something. And sometimes you miss an index in a table, or sometimes you forget to cache something that needs to be cached, or sometimes something gets hammered with requests harder than you thought it was going to. And that can cause a whole site to slow down. So it's not just the hardware that affects your latency, of course. But I was just arguing that, or I was trying to argue that, you should get as much hardware advantage as possible, because optimizing your site from a code perspective is hard and expensive because you have to pay salaries to do that. Any other questions? OK, thanks.